So thanks, Bob, for asking me to stand in. As you can imagine, being asked late morning and working out there chatting to people wasn't really a great opportunity to put together a presentation, learn the content, and get it completely focused to the themes of the day. But what I thought would be useful would be to perhaps talk a little bit about some of the capabilities that Cisco networks provide for that convergence piece, whether that's IP telephony. I put there the sort of the VoIP IPT unified communications as a continuum, and I thought it might be worth just running through some of those points. It's going to be very relevant to you if you already have a Cisco network, or if you're thinking about network refresh and thinking about Cisco, and obviously deploying Cisco unified communications. Unfortunately, I have an axe to grind there, so hopefully there'll be some interesting things in there. Hopefully you'll find it a good use of your time, and we'll go from there. So I think sort of to start off really with a point around collaboration. That people want to collaborate their way. I think we talk an awful lot about unified communications, but even myself and my colleagues who have all of the wonderful gizmos and tools on our desks, I don't really think we necessarily communicate in a unified way. Everybody has bits of the unified communication suite that they like to use, whether it's IM, whether it's presence, whether it's meetings, whether it's video conferencing. People want to consume the capabilities, the bits of the capability, maybe the complete feature set, from where they are, from what device they're on at any point in time. Now, of course, against that, IT are trying to balance the user needs against the business needs, whether that be manageability, security, cost, simplicity, the people that they've got to run the platforms. So there's a balancing act to play there. And what I've tried to do is pull out some of the things that we're doing to try and make those things easier for IT. Okay, so we can address user requirements, we can address the need for people to use collaboration, to innovate in the business, to be more agile, to be more efficient. At the same time, we can try and take out or reduce the cost to IT. So what I thought seemed to work for me, you can tell me afterwards whether you think it works for you, is to split that into three sections. The first one I've called Network Basics, and this is really the capabilities that have existed in Cisco infrastructure for a number of years and have been developed as we go along. The next piece is Cisco's take on SDN, software-defined networking, and how we actually think about outcomes as opposed to the programmability of a network. So what is it that we want? What benefits could being able to program a network as a whole piece be versus the traditional approach? We'll talk about the APIC enterprise module there. And then the final piece is around Prime Collaboration Manager, and this is sort of a new set of tools that are included within Communications Manager to help the whole life cycle of voice and video deployment and consumption. So I will start with those. So first off, if anybody's used Catalyst switches in the past, they may or may not recognise some of these things. So the first off is the ability to dynamically configure switches using a bunch of acronyms and standards, some Cisco standards. So you'll pick up on things in there like CDP, but also open standards like LLDP Med. Things that overlap, some things that we can do, some additional capabilities that we can use using Cisco proprietary capabilities, as well as the standards-based options that follow. So really talking about power negotiation, VLAN configuration, .1x authentication, QoS configuration, and security. Okay. So first off, power. Being able to plug a Cisco phone into a switch for the Cisco phone to tell the switch exactly how much power it needs. So rather than saying I am a class 1 device for 2 or 3, actually telling exactly how much power it needs, and therefore I can think about power budgets across the switch or across the switch stack, and I can then much more effectively and granularly choose what I need to spend in terms of power supplies in those switches. Okay, and that's an automatic feature up to our current switches, which support up to 60 watts, the universal PoE standard, which we're starting to see come into use in video endpoints, but also we're starting to see that come through in terms of desktops being powered over PoE. We're seeing that, starting to see that with some of the work we're doing around LAS, Light as a Service, so actually taking power over Ethernet and using that to not only control LED lighting in a building, but actually feed the power to that, and doing some quite exciting work around that as an aside. When we plug a phone into a switch, and then we plug a PC into the phone, we need to be able to think about what we do about .1x, and the fact that switches are designed to only have one device attached to a port. And of course, when we do this daisy chaining, we need to look at how we automate the trust boundary, and moving the trust boundary from the switch to the phone, and then for the phone to or the device, sorry, for the PC to plug in there and be able to authenticate as another .1x device. Automatically recognizing that there are different types of devices that are all going to plug into that into the infrastructure, and are going to need to use different power and QoS and security capabilities. So are we plugging in access points? Are we plugging in video media players? Are we plugging in phones? Are we plugging in high definition video surveillance devices, etc., etc., and being able to automate that workflow. Smart ports, another capability that exists in the switches that allows us to plug devices in, to be able to configure a port automatically for that device. More importantly, when that device goes away, we don't leave that port open. We can we'll use a macro first time and an anti-macro the second time to disable that port and take it back to where it was. Smart install is a bit more of a more generic capability, and this is the ability to, if you're rolling out LAN switches across an estate, to be able to have a very, very basic config on the switch, to be able to take it to site, to plug it into a distribution switch, and for the access switch to be able to take its config from the network. Okay, so for customers and who are looking at big rollouts of PoE switches, perhaps to support a unified comms or IPT rollout, taking a lot of the pain away of having to go plug the switches in, maybe even configure them locally or come back and configure them, plug them in. The Smart Install Director runs on one of the switches or a router in a network and can actually feed that config out to the switch. From a wireless perspective, some of the things that we're doing in the wireless world now, there's some, I don't know if there's a pointer on here, some capability that we've had for a long time in Cisco called MBAR, and this is the capability to look at different applications right down in the 4 to 7 layers, and to identify applications. We've been able to do that for a long time in the router and the switch world. What we're doing with application visibility and control is to actually then take that and put that into our wireless world. So where we have no real quality of service control in a wireless world, because everything uses the same port. Here, what we're able to do is identify applications and to actually provide the appropriate control over those. As an example, not a Cisco one here, but just as an example, if you take Microsoft Link, and I'm pretty sure this is still the case, Microsoft Link doesn't mark its packets from for quality of service. So what we can do here in our wireless network is actually look at what's coming through and then remark packets so that future packets coming from that application in that application flow get treated in the appropriate manner on a wireless network. Of course, with Cisco applications, then that's all done at an application level and everything's very well behaved and everything else. You know, you can just trust it. Okay, so that's a really useful feature. That's just come in the last couple of releases of software on our wireless system. Okay, means we can do all sorts of granular control there. We recognise, I think the number's up to about, I think it's in the close to 2,000 different applications that we can pick up on and apply appropriate policies to. And you can also build your own. So if you've got applications in the university that you're particularly interested in prioritising, then you can absolutely do this yourself as well. Okay. So that's some of the sort of things that come as standard. Next thing is really around SDN, software-defined networking, and what we're doing there. So, you know, some pretty bland statement. What your network has to be today: innovative, agile, and fast. And probably the agile and the fast, you know, are right up there. What Cisco has done, and I apologise, I missed changing one of the colours in the slides when I put this together. So it does actually say in that slot down there, I think it's Developer API, 1PK, OpenFlow, CLI. So taking the SDN concept, which I guess you're familiar with, of separating data plane and control plane and the switch, most of the froth around SDN as being, well, if we separate out the intelligence, then we can use nice, cheap, dirtbag, vanilla switches in the network and have all the intelligence in the controller. Well, that's all very well if things like OpenFlow provided any more capabilities than, you know, kind of base set of features. Cisco's been very focused over the years and continue to be in terms of providing network infrastructure that provides the sum value of the software and our own silicon designs to give flexibility to what we do. So what we don't want to do is miss out on what the opportunities are from a programmability and automation perspective in the network, because we're using our own silicon. Also, what we want to be able to do is we actually want to be able to think about all of the network infrastructure that's already deployed in customers' networks and not tell them, actually, SDN really only works for you if you take all of that out and replace it with something. So from an SDN perspective, what we're saying with the enterprise APIC enterprise module is that we can take our existing installed Cisco infrastructure and future products and be able to deliver on some of the promise of SDN around outcomes. Okay, and if we think about what those outcomes might be, let me go back one slide first. I'll get onto the outcomes in a second. In fact, I'll go back 2 slides. So what we've talked about this control layer, and what we have then is a set of APIs that connect into our network elements, and then a set of APIs that go northbound to connect into services, applications, whether those are our own products, things like Cisco Prime for management, Cisco ISE for policy, security and policy, whether they be third-party applications in terms of application services. All based around all of the kind of open standard stuff that you'd expect, RESTful APIs and all of those things. What we thought was, well, that's all very well. We can provide a set of APIs, but actually day one, customers want to see some benefits, some outcomes. So what we decided to do was actually launch the Enterprise APIC with some built-in applications, or some built-on applications, if you like. And some of the things that we think of where customers have problems is, if you think today you manage a network, you manage it as a series of boxes rather than, for want of a better word, a fabric across the network. So what we're doing with the APIC Enterprise module is actually being able to look at that network as a whole, manage it, and more importantly, configure and maintain as a whole. So things that give people problems: ACLs. People put ACLs onto switches, onto routers. They're there for a purpose at a point in time, and they never get taken off, because nobody ever knows what they were there for in the first place. A few weeks later, it's all forgotten. So you end up with massive ACLs on switches and routers. Nobody knows what the net effect of taking those things off. So one of the applications that comes as standard is an ability to manage ACLs. So look at what ACLs are doing, if they're doing anything at all, and to simplify that. On the other end of the spectrum, a topology view that looks at the topology of the network, both from a physical and logical perspective. IWAN provisioning is actually in the space of more in the space of WAN customers with lots of branches in the branch network. One that's quite interesting is quality of service management, for a better user experience. And quality of service, what are you afraid of? It says. Complex and tedious to implement. Remember what I said? Typically, we have to configure on a switch-by-switch basis, which is time-consuming. Different switches, different routers do different things, have different capabilities, different buffering. All switches are not the same, right? And then once you've done that, it becomes quite difficult to troubleshoot in the network. So what we do with the Enterprise APIC Enterprise module is to actually take some of the capabilities that we think of in the switch-by-switch basis and automate that across the network. So taking the Cisco validated designs, Cisco validated designs have been posted on Cisco.com forever and a day. They are how you program, how you should build a network, how you should configure that network, how you should configure the devices in the network, how you should configure the capabilities of the devices in the network. Taking that Cisco validated design and automating that through templates that can be applied through the Enterprise module. Being able to look at compliance on the network and whether or not we flag any challenges to that compliance. And then a third one, which is Follow Me QoS. Again, probably not too relevant. This is more relevant to customers who have multiple sites, and they might have a director who moves from site to site, but when they move from site to site, they want to take high-definition video with them wherever they go. And so we can use this to make sure that when somebody logs onto the network, when we know who they are, we can apply a quality of service into the network based on that user. So the Enterprise module, APIC, sits above the network. It takes those feeds in from, as I say, from the validated designs from Cisco Prime and pushes that out to the network. So I think where the main pain savings are here are going to be in the sort of distribution and core, which has typically been the difficult place for QoS to be deployed. Okay. Compliance, looking at what's going on in the network, reporting back and dealing with that. Don't need to go through those. As an example, this is Cisco. This is Cisco's own network across the globe. 75,000 employees, 160 sites, 7,000 switches, 29,000 routers. You can see what was involved in providing the configuration across that network to deploy high-definition video to every user on every user's desktop. It was weeks of work, now taken down to hours by using the Enterprise APIC module. And as we said before, that wasn't a rip and replace of the network. It was using equipment that was already there, Catalyst 6500s predominantly. Okay. So the final one is Prime Collaboration Manager. This exists as a suite of tools that traditionally we've provided at an extreme cost. Let's put it that way. What we've done recently in the most up-to-date versions of Communications Manager is to take a fair subset of that capability and provide it as the management tools included in the license pricing for Communications Manager. So, lifecycle, provisioning, assurance, analytics, so giving that complete closed loop for all devices. First off, in terms of provisioning, how do we provision devices? How do we provision capabilities into the network? Assurance in terms of how those applications might perform and how those applications are actually performing. So we don't need to put two video endpoints into lecture theatres and try and see if they work. We can actually simulate that in the network and see on our dashboard what is actually happening there, and will we get the type of performance that we were expecting. Okay. So from a provisioning perspective, I'm not going to read out all of the points here, but what we get to is improved operational consistency and control, being able to look at role-based access for users. So if we've got different departments who want to have a different set of control, then we can absolutely do that. Okay. So provisioning, as I say, zero-touch provisioning for users, policy-based, scheduled scripts with templates, bulk provisioning, tracking of changes, who did what when, northbound API. So again, something that's coming to our Prime network management tools in a couple of weeks' time is the northbound API. So we can take a feed from other systems in the institution to be able to automate the provisioning of telephony, whether that's soft phones, hard phones, whatever. So collaboration assurance, as I said, looks at the voice and video management, providing a clear dashboard, alarm correlation, and proactive troubleshooting. So we can look at a network view to include all of our endpoints, our servers, our infrastructure. The endpoints can be physical IP phones, they could be video conferencing endpoints, they could be codecs and lecture theatres like this, they could be Jabber clients on users' devices. And being able to actually look at what is happening across the network and where there might be a problem. Okay, so we can actually identify the switch or the router or the link in the path of that call and say it's that switch. We can Prime Collaboration will tell us what's wrong with the configuration in that switch. Is it a configuration issue? Is it a CPU issue in the switch that's been caused by something else that's going on in that switch? So we can pick up on all of those things. We've got down the bottom there test links with IP SLA. So again, it's a feature that sits inside the Cisco switches, allows us to actually use to actually model traffic. So we can say, right, okay, we need this kind of definition between this point and this point. What's that going to look like on the network with all of the other things that are going on? So end-to-end monitoring, real-time diagnostics, talked about the spotting the point in the network. If that happens to be, you can see there's a couple of white routers in the middle there. So we don't know what those are, but they might be, let's say, two institution sites with the Janet service in the middle. So we can actually go and we can say the issue is on those is at that point in the in a service provider network. Okay, so lots of time to be saved using the tools there. That's probably it. There's more around the analytics and what's going on, but that once you get round to that side of the loop, then you start paying the money for the software. So provisioning and assurance for most situations is part of the communications manager suite now. So that was it really. As I say, hopefully it was a worthwhile fill-in slot. Don't ask me too many technical questions. I'm an account manager, not a technical guy. But if you want to ask any questions, I'm quite happy to try.
Thank you, Russell. Yeah. I've let Russell run into what would be normally question time in order for him to complete.
Sure you get asked anything.
But I feel sure that during the break he'd be more than happy to take any questions that people may want to push in his direction. Yeah, a big extra thank you. I think a round of applause for stepping in to help.